So yeah, welcome back everyone. So we are going to go with the first lab. The goal of this particular session of the lab is to get you acquainted with a few of the resources that you are going to use. So this includes majorly the discovery cluster, where you will be getting your GPUs to run your examples on in the future labs. And then just also to get familiar with the Linux environment. I know like there are people here from different backgrounds, so some of you might be acquainted with the Linux command line, whereas some of you might be not aware of it or haven't never used it. So we'll just try to go over some of the basics. That being said, it's good to have a good understanding of the command line for this class, because that's how you will be accessing the discovery cluster, as you will see. So with that, we can get started. And yeah, if you have any questions, so you can post it on the chat, and then Yuhi can you can interrupt. Yuhi can interrupt me, and she can tell me the questions, and we can go over them. So that way we keep the interaction going. So again, the outline of this talk is to have the basics of Unix, Linux, and how to use the discovery cluster. So we're basically going to provide you some simple information. And for your record, I've already updated the PDF on Piazza as well as in the chat. So you can open the PPT or PDF, whatever you prefer. And this particular tutorial, I'm also going to be switching back and forth between the presentation and the command line, which is not that pleasant to do in Zoom, but it's necessary for this tutorial. So that's how it's going to be. So we'll try some of the different commands in Linux, as well as how to access the discovery cluster, how to run an example there. And so again, as I mentioned, we'll be going back and forth between the presentation and command line. So what is the discovery cluster again? So I briefly mentioned about it yesterday. So the discovery cluster is basically a set of compute resources that includes CPUs and GPUs, which is partially owned by Northeastern as well as other universities in Massachusetts. So that's the server that we'll use for this tutorial. And so there are two concepts when it's come to discovery cluster. The first is a partition. So the partition is a hard partition on like specific nodes, right? So there are different partitions, as we'll go over. For some examples of a partition are, there's a partition called debug, there's a partition called express, and there's a partition called GPU. So different partitions have different set of nodes, as well as different time limits on the amount of or the jobs you can run. So for this particular tutorial, or even in the future labs, the partition we'll be using is the partition GPU. So that's the concept of a partition, right? It's a hard set of nodes that does a specific task, whether it's a CPU or a GPU. The other concept that we need to know is what is a reservation. The reservation is something that is some more like a software partition. So it gives a few users exclusive access to a set of nodes. And what that means is that when we use the reservation for this class, which I'll mention later, so then you will have exclusive access to those nodes, and other people who are not part of the class will not be able to use it. So by now, we should also ensure that each of you have access to the discovery cluster, and we'll go over how to log in. And if you cannot log in, so you can send me an email, and then I can forward it to the concerned authorities so that they can take a look at it. So there's a documentation here, which is also I posted previously as well. So that goes over what are the basics of the discovery cluster and how the partitions are arranged. So just be aware that because that document is old, the name of the partitions and some of them have changed, but the overall basic concept should be same. So how do we access the discovery cluster? The key is through SSH, right? So SSH provides a secure shell. So using that, you can communicate with the server using the command line. So it sort of provides this interface for you to connect to the server. And then you'd always be using SSH when you are logging into a remote machine. So a machine that you do not own, a machine which might be in some other parts of the world. For example, say you are using the Amazon AWS services, which are the cloud services. Then you'll be using SSH to get a login to a node and then do your work. So in terms of how to start with SSH, in Windows, we have different tools. In Windows, it's slightly bit more complicated because you need to sometimes go through third-party tools like PuTTY or MobaXterm. And I think the recent version of Windows also provides a terminal which is similar to that in Linux. So I think Windows 10 has that version, and then you are basically, it's the same way as you would do in Linux. And in Linux and Mac, SSH is already installed, so you can directly use SSH from your terminal. In Windows, it might be, you might have to go through additional steps depending on how your system is configured. So you can always look up online on how to connect using PuTTY or mobile xterm using SSH to a remote machine on Windows. So accessing the discovery cluster, right? So first thing is that we'll need an SSH connection, which means that basically all of your laptops should be having SSH or internet connection that is working. Now, the other thing is that this is the syntax for accessing a, this is a syntax for connecting to a node. So you are going to use SSH-X, your username at the rate of login.discovery.nu.edu. Or you can just use your username at discovery.nu.edu and it should be fine. So you need to replace the username part here or your username part here with your NU ID. And if you are going on a Mac, then you need to use SSH-Y and not X. So the X is basically stands for X forwarding, which is a term that is used in SSH connections to forward some interfaces back and forth across the SSH connection. So I'll just go over how I log in, and then this will be recorded. So of course you can go over it later as well. So I'm going to switch screens now for a brief while. Okay. So yeah, so since I'm on a Mac here, so do you know if everyone can see my terminal screen?
Yeah, we can see.
Okay, that's good. All right. So yeah, so I can try to log in now, right? So since I'm on a Mac, I'm using -Y as an option. So then it asks me for my password. So the password is your my NU password.
Your screen is freeze.
Okay.
We can only see the screen, but we couldn't see you type.
You can see my terminal or not?
We can see the terminal.
Uh-huh.
But we can't see you type anything.
Oh, that's interesting. Now?
Yeah.
Okay, that's good. All right. Yeah, so now I'm on the login node, right? So this is the login node of Discovery. So, people, you can try depending on whether you're on Mac or Linux or Windows. That's how you would log in. So on Windows, you might need to go through the extra step, which is go through PuTTY or mobile xterm, and you can look up online. If you have any doubts, you can ask me later on Piazza, and I can post some links on how to get access to the server. So by default, when we log into this server, right, we are getting into the login node. So this is the login node in Discovery, and this is something that you will not be using for running any workload or any application. So this is more of a gateway thing, right? So once you are here, the way, and I'll go over it later, is to access a compute node and then run your work there. So the login nodes are specifically meant only as a gateway access, and they're not meant to run any work, right? So now if you'll go through the slides, right? So since I'm on a terminal, I'll just talk about it. So there are two ways to transfer files using Discovery. So one is SFTP and the other is SCP. So the easier way is to do SFTP, which is a secure file transfer protocol. And that way you can move files between your local machine, which is your desktop, and the Discovery cluster, right? And there are a few clients which you can use online, like graphical clients that you can use. Some of them are FileZilla and the mobile xterm as well. So let me just show you how you'd connect using SFTP to Discovery so that you can basically transfer files back and forth. So I'm going to switch screens again. So here I'm on FileZilla, which is a client that you can use for transferring files back and forth between machines, right? So the way you do it is that the first thing to take care of is the host, right? So for Discovery, you always need to use this SFTP and then xfer-00.discovery.nu.edu. So that is the host, which is the SFTP server in Discovery is running on that particular location. So you need to use that as a host name. So this is different from your SSH login, right? We do not use xfer when we do the login. So just keep this in mind. And then for the username, you need to, enter your username as usual. You need to enter your SSH or discovery cluster password, which by default is your myNU password. And then you need to enter the port number. So by default, that port is 22. So once you do port 22, it might ask something and you can just do OK. And then if you look at here, right, so you can see my I'm on my one login node. So then I can transfer files back and forth. For example, say I want to transfer this CSV file here. All I do is just drag it and then it gets transferred, right? So pretty simple way of moving files back and forth. The other way is SCP, which is through the command line. You can go over it. It's like quite simple, but again, I would recommend to use FileZilla, because when you can use a GUI, there's no reason to use the command line. So I'm going to go back to the slides again, right?
So we can do these steps by using terminal, right?
Yeah. You can use SCP to do the same thing as well.
And I have one more question about the cluster. So is there any collision on the cluster? So when many people use a single cluster, is there any collision?
Yes, so there are multiple ways you can go about it. So when you request a node using the srun command, which we'll take a look later, you can have an option called -- exclusive. So when you specify -- exclusive, it gives you exclusive access to that node for a certain time. There's always a timeout on the node. I think that is there in the discovery web page, and that depends from partition to partition. So when you are on an exclusive node, then there's no interference. But if you do not specify exclusive, then you will be having interference from other users as well. So normally when you are running like performance experiments, that's when you actually want to have an exclusive node. If you're just running like functional tests, right? So you want to see just whether your application works, then it's fine. You don't have to worry about interference. I mean, it won't happen that the other user can kill your application or something, right? So what can happen is that your performance of the application, say you're measuring a benchmark, might turn out to be slower if you are not on an exclusive node. So I would recommend using exclusive only when you do your final projects, because there your performance of the code actually matters. As well as you can use it anytime, but just be aware that there are limited number of nodes available. So when you request using exclusive, you might be put on a queue for a longer time compared to if you run on a general node. So yeah.
Okay, that's cool.
Yeah. So we've gone over this part, right? So again, for the SFTP using FileZilla, you're just going to use X for 00 and then transfer your files if you want. So now I'm going over again back to the terminal, where we'll go over how to SSH using the Linux terminal. So I'm already on the login node, right? So we'll just go over what are the basics of some of Linux as well as some basic commands now. So here I'm on the login node, right? So this particular shell that I'm given to is called as a bash shell by default, right? But there are other types of shell as well, which is born shell, born again shell, or corn shell. So these are different names of the shells, but by default it's on the bash shell. And now if I type the command who, so for reference, everyone, you can keep open slide number 13, because that's where I'm talking from now. So when I do who, it will specify, who are the people who are connected to the server. So it seems like some of the people from the class are already here on the login nodes. So even if mention that command, that's what it shows, right? And then we can run other commands, for example, right? So this is my environment variable. So in Linux, an environment variable is used to, configure paths and everything, so that you don't have to specify things again and again. And when I do echo, it mentions what is a environment variable stored there in that particular environment variable, right? So now it's showing that these are the paths that I'm pointing to, etc. So now say I want to run where is, right? So it's showing you what the file is and etc. If we want to get the full path to the current directory, right? So the current directory I'm on is home and my username, right? So next I want to see what processes I have running currently. So I do ps, and it shows that I am having a bash shell which is active, and then I just ran ps. So that's what it's showing. And then if I run exit, then I'll come out of the login node and back to my home terminal. So now other important commands which are related to navigation is, first is the cd command. So the cd command is basically stands for change directory. So for example, say I have a folder here, mnist, right? So I want to go there. So all I do is cd mnist, and then it takes me to the folder. If there's something inside there, I can view it using ls. For example, let's take a look at a folder which is not empty. So if we go to SparkNet, right? So there are multiple files here. So when I specify ls, it will show me what are the different folders and files that are available here. There are multiple variants of the ls command, right? When you specify ls-l, it will show you the files along with the permissions, and we'll go over what permissions are later on. But it's basically showing that these are files that are owned by me, what are the size, when was it created, etc. Now, say I want to run an example or something, right? So then what we do is that we do // and then specify the name of the executable. So if you have any code like any C file that you compile, that's how you would do it. Then other than that, say you want to view what is inside a file, right? So you can just do cat and then the file name. So that specifies what is inside that file, and you can use different variants of cat to either get less or more information of what you want. The other important command that is in Linux is the man command, right? So when we do man, it's like it opens the Linux manual. So when you type, if you have any confusion about a command, all you do is a man space that command. So then there's going to show you what that command does. For example, here I've done man space ls. So it's showing me all the description of what this command does, what are the different flags I can pass to it, etc. So you just go over this. It's a very detailed manual, and you can find information about all the commands here, right? So whenever you see a command that you don't really understand how it works, or you don't understand the options that are provided with the command, just do man and that command. So now moving on, how do you copy a file, right, into something? So say I want to copy the file hello.cu to my folder HPC. So all I do is hello.cu. So this is my source file, and this is my destination. So now if I go to HPC, I have hello.cu, right? So I basically copy the file using the command line. And there are multiple variants of this. Again, you can recursively copy an entire directory. For example, let's try this. Yeah, so I have multiple files here, right? So I'm going to want to move this data to the HPC folder. So what I can do is that cp-r. So the R stands for recursive. And what it's going to do is that recursively, it is going to go over all the things that are inside this directory and then move it accordingly. So now if I go here again, you can see that these files were copied here, right? So it's in one go. So you can use the recursive option to recursively copy multiple directories back and forth. Now say I want to create a directory, right? So let's say GPU2. So the make dir command creates a directory if it doesn't already exist. If you try to create a directory that is already existing, it will throw an error saying that this directory already exists. So since this directory did not exist before, it's creating it, and now I can access it using the change directory, which is the cd command, right? So it's an empty directory. And then other commands that are important are, for example, mv command. So the mv command is like almost like a rename, and you can even use it to it's sort of a cut paste as well, right? So you can use mv to move things around. And say I want to delete a file, right? So let me create a random file or just delete a file here. So let's see. Let me try to delete this file check. So the rm command in Linux is responsible for that. So we do rm check, and now it's no longer there. So you can see that it got deleted, right? So the rm command is used to remove stuff from your local workspace. So you cannot go and remove stuff from other users. Only certain users with privileges can do that. And there's another command which is popular, which is the rm-rf, and that's what it does is that it basically recursively goes through all the directories that you specify there. It's going to remove everything. For example, if I do rm-rf-gpu2, it's going to remove everything that is inside that folder. So now that folder doesn't even exist. So just be careful when you use this command, because you might, so there's no concept of a recycle bin in Linux, right? Especially when you're using the command line. There are ways to configure things like that, but normally if you delete something once, it's gone. So be careful when using the rm command.
So there's no recycle bin in this server, right?
Which one? Could you repeat?
I mean, there's no recycle bin in this server.
No. Yeah, don't try to remove stuff if you want it. So
okay, thank you.
Yeah. And so now let us take a look at files and directories. So this is slide number 19, and we just want to see what are the things that appear when we use the ls-l command. So the important thing that I'm going to talk about first is this part, right? So this specify the permissions that the user has. So the user depends on you, will have certain permissions to do. For example, for me, this is my local file, right? So the R stands for read, W for write, and X for execute. So I have executable permissions on this file because it's an executable binary. And then for other users, they only have read, right? So this one second means groups, right? So Linux has this concept of groups. And what that means is that, for example, if there's a group called GPU, then that group might have certain permissions that may or may differ from the local permissions of the user. So the default way in here is that all other users in this group have read permissions, they cannot write, and then they have X permissions, which is execute. And then there are the third category of permissions here. They refer to the permissions that belong to all the users of the cluster. So I'm not sure how Discovery configures it, whether there are groups maintained or not. But if there were groups maintained, then the groups people can do this, and all the other users can do this. And this depends on how the user changes the file permissions. For example, you can change the file permission so that only you are the one who can execute it, and so that depends on what you want to do. And then the next thing to go is this particular column. So this refers to the owner of that file, which in this case is my name, and then the users, which is the particular group mentioned here, then the file sizes, and then when it was created, etc. So all the statistics about the files on the cluster itself. So now you can use the change mod command to change the permissions of a file. So there are certain codes that are available, and you can look up online into what the different codes do. But basically, if you specify a code and then on a file, then you can actually change it. For example, let me try something here. So I basically changed this v@.c to execute permissions. So you can take a look at what this code does online, but it's basically specifying a sort of a bit mask to change the permissions. And so I changed this permission to executable for this file. So if you want to change your permissions and play around, you can do that using the chmod command. So now let me just write a very simple program and see how we can compile it. So since this is a simple example, I'm just compiling on the login node, but normally the recommendation is to always get a compute node first and then do your compilations. Right, so I have a basic program in C, which all it is doing is adding two numbers. So I want to see how I can compile it using the command line, right? So any interface to Discovery is through the command line. So people who have used mostly desktops and never or remote machine, you might be used to running your code through something like Visual Studio and running compile button there. But here, everything is going to happen through the command line. I mean, there are ways you can configure your server to work with Visual Studio, and you can look up online as to how to do that. But it's always good practice to learn the command line so that sometimes it's much faster than going back and forth between your GUI interfaces. So to compile it, I'm going to use the GNU compiler, which is GCC. And then the file I'm compiling is v@.c, right? So by default, this will produce an executable called a.out. If you do not specify any file name, That's what it does. And then I can run and it shows the value of C, which is the output, right? And if I want to specify an output executable, then what I do is specify using the -o flag. And then again, the same thing, right? So that depends on your preference, but it's always good to have an output name so that you don't overwrite anything and you know what each file means. Right? The other option is to generate assembly from your code. So that will generate another file, right? So I think it's the vadd.s file, this one, right? So this one contains the assembly for this particular code. So if I open it, and I'm not sure how many of you are familiar with assembly, but it's basically showing you the assembly version of this code. I think people who have taken computer architecture class might be familiar more with assembly code. So this one, if like in case you are interested, it's not necessary to look at the assembly code, but you can always get that using the -s option. The other option is to also, another important options basically is to specify optimization flags. So in GCC, which is the GNU compiler, we have the -o flag. So what this does is it applies a specific level of optimization, and there are different flags, like I think O1, O2, and O3 in GCC. There might be more, I'm not aware of that, but the basic idea is that if you want your code to run the fastest, then it's worth trying out different optimization levels. So far, all of the code that we are looking at is basically just how to run a compiler on the Discovery cluster, or for people who are not familiar with the command line. So this is about compiling, right? So this is not about compiling GPU code. For GPU code, you have to use a different compiler, and we'll go over that later. So the next thing that we come to, which is in slide number 26, is text editors, right? So text editors are important because on a terminal machine, like for example on Discovery, you will not have access to a graphical user interface. So you need to learn how to use a remote text editor. So some common text editors that people use are Emacs and Vim. And Vim is the one I'm going to show here. I'm not familiar with Emacs, but you can try and see what suits your flavor. So the way you do is that you run vim, and then you specify what you want to open. And so if I specify something that doesn't exist, right, so then it will create it. For example, let's try this. So this is an empty file, right? So now if you want to write your commands or write code and everything, so the basic one of the important options to do is you press your I. That moves your editor to insert mode. So when you use I, it moves your editor to insert mode, and then you can start typing. Right, so the typing is basically the same. The only thing is that you cannot move things around. For example, if I click here, the cursor doesn't move. So you need to use your keyboard to move things around, because that's how the text editors work. There's no concept of a graphical interface here. And there are a lot of Vim commands. You can always become a Vim wizard if you want, and learn the different commands. But it's good to have a basic understanding of what each command does. For example, if I want to just remove stuff, I can just press my delete and move the backspace command, and then it works accordingly. And if I want to save this from a command, save this file to my machine, what I do is I first press the escape key. So that takes me out of the insert mode. Then I press shift:. That brings me to this. So if you look here, right, the double colon, and then if I do WQ, so what it's going to do is that it's going to write to this file, because if you remember, this file was not created before, we just created it. And then we press Q, which means quit. So it's going to save and quit. So that's it, right? So now this file is saved, and I can open it again in Vim, and I can take a look at it, right? Fairly straightforward but Vim takes some time to learn, although the basics are straightforward. If you want to do a lot of advanced stuff, which is also possible, you can learn about it. It's quite a fun tool. So there are some advanced commands in Linux, which I'll not go over here, but they're basically used mostly for searching a specific string on your file. For example, if I do something like cat vnew.c, so remember, the cat command will show you what's present inside a file, right? So now it's showing me that, okay, this is the contents of your file. Say I want to search for a specific string on this file. So then in Linux, we have the grep option to do that. So the way I'm doing this, what I mean is that I'm passing it through a pipe and then do grep main. So you can see that it's searching for the string and then showing it here. So basically, yeah.
So I have a question about the command. So what does the GCC 03 means?
It's an optimization level, right? So different optimization levels might impact your performance of the code. So it impacts two things. First of all, it will impact the size of the binary that is produced, and then it will impact the speed of the code. Like this code, it will not affect because it's fairly straightforward. But some complex, if you have a very, complex mathematical application or something, then you can try different optimization levels to see which one gives you the best performance, because the performance will change for sure.
Okay, thank you.
Yeah. So this is done by the compiler, right? The compiler, looks at your code and sees that, okay, how can I make it more efficient? And then it, rearranges stuff internally. So you cannot see that unless you look at the assembly code. So for people who have taken the computer architecture class, you might have been asked to optimize using assembly or something like that. So there you can, if you go to the assembly side of the code, you can actually see what each of these O flags do. For example, they might rearrange the loops, eliminate a lot of dead code, and do some, loop unrolling, etc. So these are all concepts from compilers that are used. So there are similar other advanced commands in Linux, such as sed and awk, but they are basically used all for, moving, grepping things and, parsing a string, etc. All that kind of stuff, like find and replace. So again, as I mentioned, right, so now I'm on the login node. So when you are in a login node, the basic idea is that you need to ask for a compute node first, right? So if you're running a workload, for example, in our examples, we'll be running GPU code in the future labs. So there you need to ask for a compute node first, and only then you should be executing stuff there, because the login node is mostly main as a gateway, right? So the discovery cluster, right? So as I mentioned, there are different partitions available in the cluster itself. And then the different partitions, some of the popular ones right now are debug, express, short, GPU. Then there's a multi-GPU partition as well. So for our class, we'll be using the GPU partition, but we have a specific reservation, which I'll go over in the later slides. So this reservation, right, is named as GPU class FL20. So if you go over to slide 34, so what these GPUs have, or this particular reservation has, is K20 GPUs, which are from the NVIDIA Kepler family. And that's what you're going to run your workloads on, right, including your final project. And specifically, the final project has to be executed there because there has to be a fair environment for everyone, right? If everyone is running on different hardware, then it's hard to compare who wrote the better code. So even if you are running the other labs on your local machine, the final project has to be executed on the K20 in Discovery. So that provides a fair chance for everyone for the final project. And then, as I mentioned before, we have a reservation for this class. So the reservation grants each user that is part of this class exclusive access to the set of nodes. So to this set of nodes, your friends who are not part of the class will not have access to, because you have been specifically provided access to this particular reservation. So we'll go over how you can access a reservation itself. So first thing is that it's always recommended to store most of your files in a folder called Scratch. So the way you do it is that make this Scratch, and then you can specify the environment variable, which is user. So I'm not going to do it because I already have my Scratch folder ready. But what this environment variable user stores is your username, right? So if I go to Scratch and then user, so now I'm in my Scratch folder. So this is where my Scratch folder is. And normally, like Discovery people have recommended that you should, store most of your files here, because that provides a higher data size, like a lot of petabytes of data. So it's easier for them to manage data. The only thing that, if you look at slide number 36, is that if you wrote your code stored in Scratch, you should copy it back to your home directory later on. Because the thing is that the Scratch, they might delete it without notifying you after you are inactive for a few months. So say you did the class and you attended everything till November, you might want to move your code back to either your local machine or to the home folder, right? So that way you ensure that your data remains persistent, because they kind of clear out Scratch, sometimes depending on the time of the year. And they usually send out a mail, but better to be safe. So to run any code on discovery, the basic protocol is to use what is called the Slurm. So Slurm stands for Simple Linux Utility for Resource Management. And it's like a resource manager. So the basic concept is that you ask Slurm for resources. For example, what type of node you want, how many cores, what your partition you want, how much memory, what is a reservation ID, etc. And then your code will execute there once the resources are available. So there are two ways to access Slurm, and we'll go over each of them, right? So two very different ways, but the idea is just the same. So some common Slurm commands, if you look at slide number 38, the first is an important command called sbatch. So the sbatch command is followed by a file name, which is your batch file. And we'll take a look at an example later. But the basic idea is that this will send the job that you want to execute to the scheduler. So once the scheduler receives your job and then it sees that there are free resources available, it will execute it. So this is one way to do or run commands on Slurm. The other option, which is also popular, is srun. So using srun, what you can do is that you can request a bash shell on a particular node. So right now I'm on the login node. I'm not inside any compute node yet. But if I run srun, then what I can do is that I can ask the Slurm for a bash shell on a compute terminal. So then I have access to that compute terminal and I can start compiling stuff or running stuff there. But it depends on how you want to do stuff, right? So you can use sbatch or srun. So I think normally they recommend using sbatch because it's easier to manage. The other thing is the sq command. So we'll just take a look at that. So it's showing all the different jobs that are currently running, right? So this is the partition name. It's showing that this particular user is running a particular workload, and then this is the time, etc. So you can also see your own jobs. So if I do, so it's going to show me if I had any jobs. So right now I don't. So it's showing an empty, right? So this is the columns: job ID, partition, name, user, time, nodes, etc. The other thing is scancel. So say you submitted a job to a queue, or you are inside a terminal provided by the srun command. So you can use scancel to come out of that node, and then so you can exit or even cancel your job. So the option is there. And then you have scontrol option to find more about the machine configuration and job settings, and sf, which is you have to specify the job ID there. So it will report the computational efficiency of your calculations. So in order to schedule a job for execution, you need to submit it to Slurm. The idea is to pass in the command sbatch and then your script. And the general format for a submit script is, you provide the sbatch all the flags, and then you specify what code you want to run. And then the scheduler will schedule your code on a specific resource that you asked for and execute it there. And once it's executed, later on you can come back and see the result. So this is how most cluster environments work in many HPC centers today. So you send a job to a scheduler, the scheduler sees, okay, like all the nodes are busy, so it will put your job in a queue, and then it will execute it when resources are available. So now in slide 40, we come first to srun, right? So remember, there are two options to run Slurm. The first is srun, and the second is sbatch. So the advantage of using srun is that you can run a node interactively. So what that means is that you can go on a shell and run your code and see the output right at your terminal. So you don't have to write a batch script, etc. So let us take a look at the different options that are available. So if you do srun-help, it will tell you all the different flags that are available. And we'll go over what the basic flags are. You don't need to know all the flags. For example, the -p option or the -- partition option specifies a specific partition that you requested, which for us is going to be the GPU partition. And then there are other options like -- exclusive. So which I mentioned before, is that if you want exclusive access to a node, then you need to specify -- exclusive. and then no one will step on your job or interfere with that. So first, let us create a small example, like a bash script, which is bash example.sh. So what this script does, right? Quite simple. So it has this command that it's running a bash script. So this is a starting line for bash scripts, specifying. So the command we are interested in running is echo hello from host, right? So your host is stored in this bin host name, and then we are just going to see what host we got. So let us see how we can run it. So we'll go over running it both using srun and using sbatch. So for srun, if you look at slide number 42, the command is srun -n. So these are the number of nodes I want to execute this job on. -p. -p is for the partition. So for now, let us just try the partition express and then run this, right? So it shows your job is queued and waiting for resources. Then it shows job has been allocated resources. So that means that Slurm took my job. It found a node that was empty and then ran my job there. So here it specifies what we wanted, right? So it ran this job on 5 nodes. We got the names of those compute nodes. So in case you're wondering what is this C0160, that's the compute node that this job was executed on. So since we specified and 5, it executed on 5 different nodes. So you can change that and see what happens, right? So you see, as you see, sometimes it's just queued and waiting for resources. So this will happen if a lot of users submit jobs at the same time, and then it's going to take a lot of time to get the output. So you can see now that it ran only on 1 compute node, and it shows that it executed on C0180. So this is how you run using srun. We'll go over other examples of srun as well, how you can get an interactive shell. So now the other thing that we want to create is how you can run this using sbatch, right? So what the idea is that, okay, this is the thing that we want to run, bash example.sh, and we want to create a submit script, which is what is used when you use sbatch. So the script, which is there in the slide number 42, is hbash example.script. So again, we specify that it's a bash script, etc. Then here we are specifying the partition name. So another popular partition on Discovery right now is debug, similar to the one we use Express. I think they have different timeout and different type of nodes, etc. Then we are specifying -- nodes equals to 5, which means that we want our job to execute on 5 nodes. There's no these are not GPUs, right? So since we are on the debug partition has CPU based nodes. And then this is quite important, right? So which file or what is the name of your output file. So you need to specify that here so that after your job runs, you can see the output in this particular file. So you need to specify it correctly so that you're not wandering around looking where your output went. And then the last command is what to run here. So we're specifying that this is the command I need to execute, right? So scratch, this is where my code is located in. This is my username. So you need to replace this with your own username. And then this is the script I want to execute. So if I do sbatch, so it says submit a job, right? So now we wait for a while, but what we can do is that we can check the status of our job using SQ. So it seems the job already ran. So sometimes it's quite fast, but in case your job is stuck, you can take a look at the status using SQ-U, and you will see what partition your job is running on. So now you can see that the command previously what we got in the terminal output, now we are getting in this particular file myjob.out. So in case, so whatever you are moving to std out, say you are printing the 2 matrices or whatever you're printing, right? So that will get stored in this output file, provided you specify it correctly, and then you'll see the output here. So this is how you would run using sbatch. So now the other thing is that we always need to set up our environment. so that we can have access to all the tools that we require. So if I do module, I believe the command is avail. Yeah. So this shows you all the different software that is available on Discovery. So for example, let's see. Yeah, you can see that these are the versions of the popular programming language Go that is installed. For Python people, you might know the Anaconda package. So these are the versions of Anaconda that are installed here. And then for GPU, we need CUDA. So these are the versions of CUDA that is currently accessible on Discovery. These are the versions of MATLAB, etc. So you can take a look at all the software that is available on Discovery. What you cannot do is that you cannot install your own software, because mostly installing your own software requires you administrative privileges, which you don't have by default. Even I don't have. Only the people who handle the Discovery cluster have that permissions. So if you have a very specific software that you need for your work, for this class, you probably won't need it. But for your work, then you need to contact them and ask them to install the software. And then they will take a look at your case on a case-by-case basis and then install the required packages. So the way the environment gets loaded, right? So when you log into through a terminal, so what happens is that you have a script called bash rc, right? So every one of you will have the script by default, and this is how you access it. So if we open the bash rc file, it does all this. What color is my terminal, etc. But the important thing that you want to take a look at is here. So what it's mentioning is here the module load, right? So what it does is that whenever you log in on a Discovery node, by default, your environment will load these packages. For example, I'm trying to load CUDA 9.2, Python 3.7, OpenCV, OpenMPI. So depending on what package you want to load, you would want to mention this under module load. So for your particular file, you won't have these module load options. So you should put them. And I think in one of the folders, we have an example of a bash rc file that you can modify or play around with. But it's always good to load your modules so that you don't have to do it again and again. And the other thing that I'm doing is that I'm specifying some Slurm aliases. So the alias is basically a shortcut, right? So instead of sq-u user, I can just type sq. So you can take a look at that right now. So see, but if you try this command yourself, it may not work because you don't have the same shortcut configured. So alias is just a way to create some shortcut commands that you can use. For example, if I run GPU on my system, it will try to run this srun command, which is basically going to ask for a GPU on a particular node. So now the important thing is how do we access the class reservation, right? So if you look at slide number 45, that's where we have this. So there's a test job that, if you are already logged in, you can all run. So I'll run it from my end here. So this is where I'm specifying -p is the partition, which is GPU, and -- reservation, right? So that's GPU class FL20. This is the X11 forwarding. I'm asking for 1 GPU, and then I'm going to execute a command which is called NVIDIA SMI. So what NVIDIA SMI does is that it basically shows you what GPU is on that resource, etc. So what is the utilization of a GPU? So there you go. Right. So what this command did is that basically it allocated a compute node for me, ran this command there, and then showed the output here. Because it's srun, so you're seeing it on the terminal itself. So NVIDIA SMI is basically a NVIDIA tool that shows you, what is a GPU and how much memory is available, how much it's currently utilized. So it's showing me that this particular GPU is now 97% utilized, etc. So the other option, or one important thing that you might have to do later, is getting a bash shell on your compute node. So remember, again, there are two types of nodes on Discovery. There's a login node and there's a compute node. So you cannot compile or heavy jobs or run like parallel applications on the login nodes. If they find you doing that, they are going to complain. So what you need to do is, you need to go to a compute node and then execute a job there. We'll take a look at how we do that. So again, we are going to use srun. So it's going to export all my environment variables from here. I'm going to specify the partition. I want one node. So this is the reservation name again. I also need to specify how much time I want it for. So for now, I'm just specifying 20. So now you can see that this particular thing changed, right? So previously I was at login 01. Now I'm at C2159. So this is a GPU specific node. And if you execute NVIDIA SMI here, you can see that there's a GPU on this node. You can see this is a GPU that is already on this node, right? So it's showing the versions and everything. So now I'm inside a GPU node. What that means is that later on in your future labs, when you're going to run experiments, you're going to have to move to a GPU node. Sorry. The other option is to, specify your job using a Slurm batch submission. And once you specify it there, what we'll do is that it will move to the GPU node and execute your job there. But so the question is, when do you want to run your code on an interactive versus a batch submission, right? So if you want to run it interactive when you are, trying to develop or rapidly develop code and then compile it and start testing immediately, and say you have a large job that requires a lot of resources, but your code is already running fine, you already know that. So in that case, what you do is that you prepare a sbatch script similar to how we showed and just execute your job on the GPU. So Slurm will do that for you. And then later on, you can come back and look at the output. So just a matter of, what task you are up to, and then you decide whether to use srun or sbatch. So now if I take a look at SQ again, or even the short form, right? So you can see that I have been allocated a job ID. This is my node that has been allocated to 159. I have so far ran for this much time. And since I asked for 20 minutes, after 20 minutes, it's going to expire. And then I might have to ask for a new node. So I believe they have a hard limit on how much time you can ask for a specific node. So this ensures that people don't occupy the node, forever. So you can take a look online. I think they believe it's up on the discovery web page on, what are the time limits for each partition. But generally speaking, you won't have to run for so long. So for this class, at least, you basically get your node, you go through the lab, you run your examples, and then you are done. Maybe for the final project, you might need to run longer, but it won't be for 24 hours for sure. So now if we move to slide number 48, there's some hands-on experiment example that you can do. So the idea is there's a folder there, right? So for me, I've already copied it. It's called HOL1. So you can copy it using the commands there. They can just copy paste the command that is there in the slides. And then, you can look inside. So if you go inside, right, the main folder, you'll see there's a file called tutorial.tar.zz. So you need to decompress it. And to do that, you use ZXVF. So let me just remove it here. So yeah, big folder, so it takes time to remove. So you can see it's extracting all the information from this tutorial. So this particular folder is owned by the guy who developed the class. So I think there's some important information here that you can use. For example, if you go to the scripts folder, he has some scripts which you probably want to use later on for collecting your experiments. So these are like, probably have to go through each of them later on, and I encourage you to do that. So basically all are these bash scripts that are, trying to do something like running an experiment multiple times with different block or different sizes of data, etc. So you might find these scripts useful in your future labs when you have to, run experiments and compare results. So what the idea of these scripts is to automate a lot of the tasks that are quite labor intensive, but if you do it using a script, it's much easier to get these things done. I believe the other part that he has here is, yeah, these are some results folder that he has put for just for, experimentation purposes. And then these are the bash scripts that he has provided. So yeah, just take a look at what is inside there. You'll probably find these scripts inside, which are quite useful. But you need to understand how to write a bash script for that. So if for people who are not familiar with writing a bash script, you might want to go over what the syntax for writing a bash script first is before you take a look at the scripts. So, just try to go over them in your off time. And then again, just the basic, like for those of you who are new to Linux, it's quite straightforward. All you need to, like there's a small learning curve to it, but the basic idea is that, you run commands, you ask for things, or you move stuff. It's just that you need to get the concept of a GUI, put it aside for a while and think about how you can do things using the command line. So everything that you do or any command that you want is available using man option. So just pass it the command and then, you can get the information. And, the community is so big around Linux that you can find any information online. So if you're having a specific trouble, you should always be able to, just search and get it right away. So most of the stuff is quite straightforward. And then definitely, as I mentioned, you can take a look at the scripts for future recollection and whenever you want to run your experiments. And there are some scripts which I'll post later. So those are sample bash RC scripts that you can also use similar to how I have mine. So the idea of the bash RC script is to, configure your environment so that later on when you log in, you don't need to do anything, right? So your environment gets loaded automatically. And that way you do not have to load your modules or specify paths, etc. So that's the basic idea. And again, this document that is linked in slide number 50 is quite important because it goes over what are the things associated with the discovery cluster. So again, just take a look at that so that you are familiar with how the cluster is set up. So far we have gone over what the basic commands are, what is the difference between a login node and a compute node. And that's always something that you want to keep in mind, that whenever you're running your labs, or even in the future whenever you're running any work like a proper application, not like the vector add example that I showed, then you definitely want to first get a compute node and only then you can execute stuff, right? So by default the compute node has access to all your folders, right? So remember when I logged in from the discovery, right, previously it was at login, I still retain all my folders. So you don't have to move stuff between, here and there. So by default, you'll see most of the folders already there. So just for reference. And then, yeah, that's it for this particular tutorial and lab. So for the next section, next week, you will cover the basics of CUDA programming. So that's when you'll get to start to play around with like some simple GPU examples. And then the following lab in next week will allow you to run basic GPU applications and see how they work. So that's quite exciting, and you get to see how a GPU program is different from a CPU program and how we compile it, how we execute it, etc. So yeah, so just look forward to that, and that's it for today. So with that done, if anyone has any questions.
So I have a question. Like, are we gonna talk about the HPC topics?
HPC topics like what? HPC is quite broad.
Just general, parallel computing.
Yes. So some
algorithms.
Yeah, the parallel algorithms will be covered. Things like parallel reduction, parallel scans, parallel histograms, etc. So, but we are going to talk about it from a GPU programming perspective. So HPC is quite a broad term because we're not going to cover things like MPI or OpenMP here. It's all going to be focused on programming on GPUs itself. So these algorithms are going to be programmed specifically for GPUs. So in that sense, it's not like a broad HPC based focus.
Okay, thank you.
Is that clear? Yeah. I guess, yeah. If anyone has any questions, then you can always post on Piazza as well. So we can get back to it later.
So I will stop the recording.
Okay, yeah, sounds good.